Now these are all the materials that we're going to need to build this antenna. I've got some coax here, pretty decent coax this. Most important thing is to make sure it's 50 ohm and it's got a nice tight braid so we can flood solder into this to solder up the antenna as we go along. I've got a mixture of brass and copper for this one because I didn't have the brass in the all the diameters to do the antenna. I didn't have copper in all the diameters to do the antenna, but basically we start off with this one here. This is some stock copper tubing, and this is 22 millimeters in diameter. What I did, I soldered on a piece of copper sheet at the bottom here and then drilled out a hole the correct diameter to take this N-type connector, because that's what we're going to use to connect to this particular antenna. And to connect the coax to this, I've got a piece of tubing here. This is 5mm diameter tubing. I'm going to be soldering that on the top of the N-type there and using that to solder my first copper piece there. So that's going to stand in the middle, and then we're going to solder the coax as we're building up this antenna, starting there. And because this is shorter than the length of this piece, this is a quarter wavelength at 31.5 millimeters, it's not going to radiate there, so it's just basically a transmission line, a feed line for the rest of the antenna. Now for the main body of the antenna, we've got some quarter wavelength and half wavelength sections of this brass tubing. This is 10mm brass tubing that I've got here. This one is a quarter wavelength at 31.5 millimeters, and we've got two of those, one for the start and one for the end. The end is also topped off with this here. This is some copper tubing again, and this is 12mm in diameter, and basically we're going to be cutting a notch into this and finishing off the antenna. We'll see as you go along when I build this. This is a little bit longer at a quarter wavelength. It is actually 37mm that I've cut off here, and that's basically so when we get this on the end I can tune it and get it to the right length at half wavelength here, with it terminated in this area here, so we can solder it on there, so it's a little bit longer. And now the main body of the antenna are three sections of tubing, and these are made up of half wavelength sections, but these I've measured off at 55mm instead of the 63mm that will be half wavelength for 2.4 gigahertz. And the reason I have done that is because we need to take into consideration the gap here when we're building the antenna, and that gap is around 8mm. You can see I've got here, so we have to factor that 8mm into this half wavelength, so we reduce it slightly. But that's all the materials that we need to build this antenna. Pretty straightforward. I'm going to be building three of these, three different methods, and what we're going to do is compare all three together to see which one is the best. This is probably the most complex one, so I've chosen this one to build first. Now the first thing I'm going to do is put the ground plane of this antenna together. I'm going to be soldering my little piece of tubing on here onto the N-type connector, and then bolting the N-type connector to the ground plane tubing here. I've also modified the nut a little bit. I've ground it away so we can slip that on the inside of there, and then we can get some long needle nose pliers and then get it all tightened up in there. So that's the first thing I'm going to do. Now, because normally with this you wouldn't use such a wide diameter with this, you'd use wire that would fit inside the solder cup, but basically I've tinned up here. I'm going to place that over the top. I'm going to break off a few little pieces of solder, pop them in, and then I'm going to warm this up with a blowtorch and just let the solder flow around there, and we'll get a good connection. Just use the blowtorch, get a little bit of heat in there, just enough to make the solder flow. That's plenty. That's a really good strong connection there, nice and straight, so we can solder onto the top there with our coax. So I'm just going to pop everything else together now. So now we're going to start work on the main elements of this antenna. So I've got my coax here, and I want to make sure I leave myself plenty at either end to work with. So I think For the quarter wavelength one, if I cut the coax off about there, that should give me plenty of coax to work with. So I've got my length for coax, and I've got my outer sleeve here. I'm just going to use it to measure off. So I'm going to put a little mark there and a little mark there, and what I'm going to do is strip off this outer PVC to expose the outer braid on this coax. And you can see I've got the outer braid fanned out on this piece here, and basically it's going to go over there. We're going to solder it in position there and cut away any excess. But you can see I've pre-tinned the end of this brass tubing here, and I'm going to pre-tin the other end as well. But a little trick when you're using something like this, and probably be even worse with copper as well, is because it acts as a giant heat sink. The best thing you can do is get your blowtorch, get a little bit of heat into that. You don't want it red hot, just a little bit of heat like that, and then get your soldering iron and then flow some solder around the top here. If you try and do it without getting some heat in there with a blowtorch, it's very, very difficult to do this, because it just sucks away the heat from your soldering iron. So you can see how I've got the braid in a sort of dish shape, and what I'm going to do now is just flood some solder into that. Just work my way around. Now that I've got that one end prepared, I'm going to get some heat into this tubing again, pop it over the top, and then with a soldering iron get all that solder to flow so we've got a nice joint. I'm going to try and show you this on camera. A little bit of heat in there. That's enough. Pop that over the top and get my soldering iron. And there we go, got a nice joint there, and when this cools down what I can do is just get in there with a Dremel and just remove any excess that's around here, just to tidy it up a little bit. So this is what it looks like now it's cleaned up with a Dremel, and that's how you want it. We've got about 5mm of the dielectric insulator there, and you know, expose this piece here, which I'll tin up later when we're ready to solder all these up. But now I've got to do the same with the half wavelength elements and the other quarter wavelength element, but basically just the same as what you've seen here. Now, as you can see, I've got them all soldered up. I've gone in there with a Dremel, cleaned away the solder, any excess, just tidied them up a little bit. I've also cut down the centre connection of the coax there into a more manageable length, because we're going to be basically soldering them like this here. One thing I forgot to mention about this coax, I also chose it because it's got a solid centre connector of copper in with this one, but you know, you probably just twist them all up and flow some solder on there, but it just makes it a little bit easy that it's a solid piece. The only different one is this one. This one's the end one, so I've got this long length of copper here, so we can connect to the end. Well, I'll show you when we're putting the antenna together. Probably way too long, but it's better to have too much than too little. So now I'm going to start soldering these up. I'm going to solder all these together and put the end cap on as well, and then finally I shall connect this up. But let's get these soldered up first. So the first one is this quarter wave. This slightly longer length here is going to go and solder down into there. So I'm going to have this way round, and then I'm going to have a half wave soldered onto that. So basically I want to put a line of tin along the side of the tubing here, tin up these, and then solder it in place. Now this tends to be the tricky part, and I've had a look at many versions of this, and people have built online, and some people even mention to build a jig. I don't think you have to go to that extent, but I've already pre-tinned the side of the tube here and pre-tinned the copper where I'm going to solder onto. I'm just going to concentrate on this side first and then flip it over and then solder on that side. And you can also see the gap here now, and that's why I reduced the length of the half wavelength to take that gap into consideration. But I'm going to solder this side on first. Should be straightforward just with the soldering iron, because I've got everything pre-tinned. I don't think I need to put any more heat into this brass tubing, but I'm going to have a go at soldering that in. So a little bit of solder on the tip to get the heat to transfer, and then hopefully get that solder to flow. Now I'm just looking at this, and yeah, the solder is flowing on the copper wire here, but it's not really flowing on the tube, so I'm going to have to add some more heat to that. So second time trying then, I'm just going to get some heat in this. I'm using my smaller blowtorch. Just want to get some heat in there, not enough to melt the solder, just to make the job a little bit easier. I think that should be enough. So a little bit of solder on the end of the soldering iron, and that looks a little bit better. Really tricky doing this on the camera. I'm still not happy with that. Let me get a bit more heat in that with the blowtorch. Some heat into the tube first. There we go. That's flowed a lot better. We've got a good connection there now. So it's definitely the trickiest aspect of this build, I have to say. Possibly building a jig, yeah, I might take that back. Possibly the way to go. But if you're just going to build one, possibly two of these, then you should be able to get away without a jig, I think. I think once you've got one side soldered on there, it's a little bit easier. You just don't want to overheat the tubing. You want just enough to get that solder to flow. That looks good. So I'm pretty happy with how they're soldered. It's not the tidiest job in the world, but we can tidy that up with the Dremel. What does count is that we've got that solder to flow really nice on the brass tubing and on the copper wire here, so we've got a really good secure solder joint. Really is, because this has got to take quite a bit of weight as well, just on these 2 points. There's nothing else holding this antenna erect, and although I'm building a small one here, I mean, you can stack these and you can get them quite long, but yeah, a little bit messy, but we can tidy that up. But at least you saw it on camera. Yeah, everything's soldered up. It's nice and straight. I would, if you're going to make one of these, even if you're going to put it inside of a PVC pipe to protect it, I am going to wrap some heat shrink tubing around these areas here. I'm going to use some clear heat shrink tubing because I want to take photographs of this so you can see exactly how I've put it together, but I would definitely put heat shrink tubing around these areas just to add a little bit more strength to it. But now we're going to do the end piece, which I'm going to have to show you. We're going to have to cut a slot into this and actually get the ruler out and measure it up, because we want the length of this from here to here to be half a wavelength, and we also want the feed point for this bang in the middle of that half a wavelength. So that's why I'm going to cut a slot up there to give us a bit of maneuvering room, and then solder this in place. Another thing I want to say about this end piece as well, I have seen this type of design before in professional built antennas, and although I'm going off a build that I found online, and I have tweaked a couple of little things with that build, on that build this is soldered in place, so we've got a physical connection between this one and this one. But all the professional ones that I've seen are insulated, so this one is completely insulated from this and any of these below, and is just connected up through the middle here. So I'm not sure about that. What I'm going to do is solder it in place, just tack it in, take it over to the network analyzer, take a look at it, and then I'm going to desolder it and then place it back on and isolate it from this, just to see if there's any real difference between them. I mean, there might not be, I don't know. Now I want to show you this bit because it's the kind of small details that people don't show, and you can see I've got the slick cut in there, and you can see how I've bent up the copper here, and this is just going to slip over the top, and the way I've got it now is exactly half a wavelength, and I've got it on the bricks here because I'm going to have to get some heat in here with the soldering iron, but I just want to tack it on just here and then tack this on just here, so you can see the feed point is in the middle and we've got that half wavelength. But as I said, I'm just going to tack it on because I want to try it with it isolated as well, just to see what difference we get. But yeah, that's what we've done at the end, and it's a little bit hard to see with plans that you see on the internet. So that's the end soldered on there, pretty easy really. Got a bit of heat in there with the blowtorch, finished it off with the soldering iron, just tacked it on there, so we should be able to remove it to do a second test with it isolated. So now I just need to solder this onto this point here. If I were to build this again, I think I would screw this on last, but should be able to get in there with a soldering iron and get it soldered up. Now I'm getting ready to solder this in place. I've got everything prepared and tinned up, but something else that I'm going to do is I've got a little nylon M3 washer here, and I'm going to put that over here, and I'm going to super glue it in place so I don't have to worry about it. And what that's going to do is going to give me an insulation between the part here, okay, from here, because I don't want it to touch this bit here. I just want it to make contact with here. Now if you want to use an M3 washer, don't buy them individually, buy one of these kits off eBay. You can pick the kit up for about $3.99, but if you want to pick up 10 of these nylon washers on their own, you're probably looking about £1.20. So it's better to buy the kit, you know. It's and you will use them, especially if you're like me and build lots of antennas. But basically now I'm going to get a bit of heat in here with the blowtorch, use the soldering iron, and get everything to melt and connect. So here is the antenna on the test bench. Then I should really have the wide angle lens on to get it all in the shot, but you can see it there. So let's have a look at the output on the network analyzer. So here it is on the network analyzer then, and we're scanning from 1700 megahertz over here all the way up to 3 gigahertz over here. Now I've got the cursor set on 2.45 gigahertz, and that's normally where we'd like it for the Wi-Fi spectrum. I'll just move it a little bit, and you can see 2.4 gigahertz there, and the kind of sweet spot that this antenna is working at the minute is 2.327 gigahertz there, so just outside where we need it to be. It's a little bit off center, and this is something I did worry about, to be honest with you, because these are old plans that people have uploaded on the internet. Did they have any test equipment to actually test their measurements? But yeah, I mean, the only other thing I can do is the theory that I had, where we desolder the top part and isolate it from the rest of the antenna, and we'll see if that makes a difference. But at the moment, yeah, it would work at 2.45 gigahertz there. I mean, if we did a Wi-Fi scan, we'd certainly pick up plenty of access points, but you know, it's not perfect for Wi-Fi. But let's try that, desolder that and isolate it from the rest of the antenna. So here we are then. I've just put some heat shrink tubing on the end of here, so I'm going to place this end piece back, solder it on, and see if there's any difference. So here we are again then, antenna set up on the test bench exactly as before, and we can see right at the top there it's now isolated. Now we'll take a look at the network analyzer, and yes, I've already had a look at this. I think you'll be surprised with the results. So here we are then looking at this, and the waveform itself has changed a little bit. We've got this dip over here now, but I've got the cursor set on 245 gigahertz, and now 245 gigahertz is in this lovely little dip. We can see it's changed a little bit. It's come more to the side that we want it to be around, so it's shifted a little bit this way. We've also got this little hump in the middle now, but it's still quite a wide band dip there, but now it's going to work perfectly for the Wi-Fi spectrum. So that's 241 gigahertz there, sorry, 2419 gigahertz, dipping down 244, and then 247 gigahertz there. So yeah, it's quite wide. Over here we've got 23 gigahertz, but it's a lot nicer. And that little change, isolating that last element, really completely shifted this antenna. And I did have my suspicions about it, but you know, whether to include it or not, as the original author that came up with this design claimed. But as I said, I've seen it in professional antennas and it's always isolated at the end. But yeah, that is nice. Nice little dip. That little change, you wouldn't have thought it had made that difference. So, would you have thought that just a simple modification at the end of this would make all the difference? I mean, when I first saw that on the network analyzer, I was thinking, oh, I'm going to have to get some more 10mm brass tubing and change the measurements in here and that sort of thing. But no, isolating that top part, which the original author did not do, has changed this antenna completely. Yes, I would like to have seen that shift a little bit to the right hand side, but it's still in there, it's still in the sweet spot, and this antenna will certainly perform. And you know, you can't knock the original author because it is an old design from the mid 2000s, and back then a lot of the homebrew guys, I mean, I was active as well too, we couldn't afford the equipment. I mean, there wasn't even the cheap Chinese equipment coming up on eBay at the time for this sort of thing, and we just used to use a program called NetStumbler, which Vista Stumbler is sort of like, and just do a scan. And yeah, there are, as I've mentioned before in previous videos, there are shortcomings with that. I mean, you're only looking at it as a receiving antenna, so you know, you can't knock the original author. But yeah, I mean, his measurements were spot on. He just needed to isolate this to make himself a sweet antenna. But even without that modification, you would probably stick this on your alpha card and it would still perform pretty well. I think you'd still be pleased with it. Now, as for my plans with this antenna, what I'm going to do, I'm going to build 3 other Collinear antennas. As I said at the beginning of the video, this one is the hardest of the 4 to build. One of them I'm not going to show the build because I've already built it before on this channel, but the other 2 builds I'll shoot videos on. Of course, we'll test each one on the network analyzer as we go along, but what I'm going to do is do a final video with a shootout with all 4, so you can see you know, the what it can pick up, and we'll do an upload and download test with each one as well, and you know, see if we can see a difference in that between all 4 antennas. But yeah, I'm pretty pleased how this turned out. I think it's a nice antenna. I mean, if you stuck this inside some PVC pipe and made it waterproof, you hook this up outside, you can even stack it a little bit more, put 6 elements in between here instead of the 3. Probably as it stands now, it's around 7 dB, omnidirectional 7 dB of gain. So yeah, Nice little antenna. So as always, a PDF will be in the description with all the measurements on, etc. And remember, you know, to isolate this top part as I have done here. I mean, you can just use some electrical tape if you don't want to use heat shrink, and you know, it's as long as you isolate it, then it shouldn't be a problem. But the PDF will be included in the description. If you did enjoy the video, please give it a thumbs up. Comments or questions, drop them below. I'll do my best to answer them. And yeah, if you want to help support this channel, please pop over to Patreon. I will be giving all 4 Collinears away when I've finished filming over on the Patreon channel. But yeah, if you did enjoy it, please give it a thumbs up, and hopefully you'll join me on the next one.